The next thing you're going to look for when you have exponential equations is to see how many exponential expressions we have. So here I have an exponential term, 4 is the base, x is the exponent, but I also have an exponential term on the other side. 3 is the base, and 2x plus 1 is the exponent. When this happens, what you are going to do is you're going to take the log of both sides, and then you'll use log properties to solve. And the idea behind this is if you have two numbers equal to each other, so left side equals the right side, well, if you take the log of both sides, then they will still equal each other. Okay, so that is the premise that we're using for these next 4 examples. So for this first one here, let's go ahead, we can pick whatever base we want. So I'm going to default just to one that we have in our calculator. So especially if you do not have the newer operating system where you can type the logs in using this, what you're going to want to do is kind of stick to the natural log and to the common log. So I'm going to use the common log, and we have here the log of 4 to the x equals the log of 3 to the 2x plus 1. All right, and what's nice is I have a log of a number to an exponent. Well, I can use the power rule and bring those exponents in front. So this becomes x log of 4 to the x equals 2x plus 1 log of 3. Okay? Now, what's going to happen now is I want to do a side-by-side with a decimal approximation for these to try and show you what's going on, and I need not to have that there. Okay. We use the power rule, so there's no x here. All right, so what I want to show you is that log of 4 is 0.602. So I have x times 0.602 equals 2x plus 1 times log 3, which is 0.477. Okay, now when you look at this, you're like, oh, how are we going to solve for x, right? And it's like, well, I could just distribute x here. So, or distribute this 0.477. So I'm going to get x times 0.602, which is really x log 4, equals, well, 0.477 times 2 is 0.954x. And then when I multiply here, I get plus 0.477. Okay, so all I did was distribute. Well, 0.477, that means I'm distributing this log here. So we're going to get x log 4 equals 2x log 3 plus log 3. So right now, I have these things on the same side. So what we're going to do next is I have two x terms and a constant. I want to get the x terms on the same side. So the best plan of attack here is to subtract 0.954x from both sides. And what happens is I get 0.602x minus 0.954x equals 0.477. And what I'm going to do here is I'm going to factor in x out, because then I have 0.602 minus 0.954 equals 0.477. Okay, so let's talk about how that compares to what we have up here. Here, we also have just the two x terms, just like we did here. And I'm like, you know what? I'm going to move so that the x terms are on the same side. So here I get x log 4 minus 2x log 3 equals log 3. And similar to what I did here, I have my two terms with an x. I factored the x out. So we get x times log 4 minus 2 log 3 equals log 3. So here's the thing. If I want to solve for x, all I need to do is remove this number. Now this is actually one number, all right? It's written as 2, but if I do 0.602 minus 0.954, this is negative 0.352. X equals 0.477. What I would do to solve for x is I would divide by this number, okay? Now I changed it so it was one term here, but what we're going to do here is we're going to leave that. So I'm going to divide both sides by log 4 minus 2 log 3. Because that value, if I plug in my calculator, that value is really negative 0.352. So for my exact answer here, I get x equals log 3 over log 4 minus 2 log 3. Now at this point, I'm okay with you stopping here for the exact answer. If you were so inclined, you could go further, right? Because on the bottom here, we're subtracting two logs with the same base. If we use the power rule, we get log 4 minus log of 3 squared, which is log 4 minus log 9, which is really the log of 4/9. You're more than welcome to do that, but I would suggest just leaving this, especially since you'll get full credit if you can get this far, okay? Because at this point, I have x by itself, and then I have log terms all on the other side. Okay, so that is plenty. So now what we need to do is do the approximate answer, okay? And what's nice about this one is it doesn't matter if you have the newer program or not, because we have a common log button. So we have log of 3 divided by, now you do need to be careful. If you're going to do this in one step, you need to put a parentheses around the whole outside here to get the whole denominator in one spot. So we got to do log 4 minus 2 log 3. Now here I have this one parentheses, but I need to end it. I need to end the denominator by adding one more, because that parentheses here is only to end the 3. All right, so we press enter, and we get negative 1.355. Okay, and then what we have next is this problem. So I'm going to take a different approach to this, all right, and what I'm going to be using for this problem is I'm going to purposely choose this log base b of b to the x property. And what happens is if the base and the base of the exponential expression, which in this case my exponential expression is b to the x, if the base of the log and the base of the exponential expression match, then the exponent is the answer. Well, that's awesome here because, especially if you don't have the newer operating system, if you have an e here, then that's really log base e of e to the negative 4x. Well, if those match, then my answer is 4x. So what I'm going to do, because when we take the logs of both sides, we can pick whatever base we want. So here what I'm going to do is I'm going to do log base e on purpose of e to the negative 4x equals log base e of pi to the 1 plus 3x. Because again, if I'm going to take the log one side, I also have to do it to the other side, and I need to make sure that they are the same base. Now on the left-hand side, we purposely chose this so this part would cancel out. So now I'm left with negative 4x. Okay? And then on the right-hand side, I'm going to use the power rule. So what I need to do is bring this in front, so I get 1 plus 3x. Instead of putting log base e, I'm going to go ahead at this time and switch to the natural log of pi. All right? And similar to the other problem, right, once we were here, what we wanted to do was distribute. So I have negative 4x equals the natural log of x, because natural log of x of pi, or natural log of pi times 1 is just itself, and then plus, and then 3x times the natural log of pi. Now I have three terms. Two of them have x's. I want to move this so the x's are on the same side. So minus 4x minus 3x natural log of pi equals the natural log of pi. Now I can go ahead and factor out the x. So I have negative 4 minus 3 natural log pi. And now we can divide. So we have negative 4 minus 3 natural log of pi. And then my exact answer is going to be easy to type in because we have a natural log button. So we have the natural log of pi. Pi is second caret. and then divided by, again, we need a parentheses for the whole denominator, so -4 minus 3 natural log of pi, end parentheses, but end it again to make sure the whole denominator is in parentheses, and then we get -0.154. Okay, now these problems, we solved them a little bit differently. One, we just took the log of both sides using the common log on purpose. Here we purposely chose log base e so that we could use the base to the base property. All right, but the other thing that we have in common are the steps that we are doing in here. Ultimately, the first step that you're going to be doing, regardless, is you will be taking the log of both sides. Okay? And then the second step that you're going to be doing for all of these is you are going to either use the power property, which is if you have log of b to the x, that's equal x log b. All right, so that's just the power property, just bringing the exponent to the front. Or you're going to be using the base property or a mix of the two. So this one is log base b of b to the x equals x. So the second step for all of them is you're going to be doing this, okay? The third step, all right, after we use the power property or the base property, is you're going to distribute, but that's if necessary. So you may not always have to do that. The only time you have to do that is if you have a binomial exponent, okay? And if you're using the power rule for that, okay? So after we did that distributing, the next step that we did for both of these is we moved x to one side. So move x terms to one side, meaning the constant needs to be on the other side. So constant to the other side. Okay, and after we did that, we factored out an x for both of these. So factor x. And then the last step is to divide. So here's the nice thing. These steps, they don't change. All right, if you have an exponential expression on both sides, you will be doing these steps every single time. Okay, so this is a nice reference. So if you want to put that somewhere to use as you're trying to do these problems, that might be a good idea.